In this video, I had to repair my Tektronix TDS784C digital oscilloscope. And it's a fault of my own, actually, because I know better. But what happened was the NVRAM that holds the firmware, the battery went flat, corrupted the data, and scope would no longer boot. So what I ended up having to do was order 2 new ones. And I wanted them new where I could replace the battery and stuff, because getting old stock is pointless because the batteries are probably on their way out on those. So there's no point in buying something that's only gonna last, maybe a few months or whatever. So I ended up getting 2 new ones from a guy in Texas, and he sells the pair for about $100. I went ahead, took my burner out, loaded 5.2 firmware. Thankfully, I have a backup of pretty much every version firmware this thing had, and that's what was originally on the old one. So I went ahead, did that, loaded it on there, and hopefully the scope will come back to life and the CPU board doesn't have any other issues. But I did have to do a couple other repairs on this scope when I originally got it, because the power supply was dead due to the secondary MOSFET being shorted. And essentially how that happened was a bad capacitor put a lot of ripple on the actual driver, which took out the MOSFET and took out the power supply. So I repaired that. And you can see I went ahead and did the LCD conversion kit on this one. The reason why I did the LCD conversion kit on this one was because the original shutter actually had delaminated and it was causing leakage on pink, like splotches everywhere and stuff, and I couldn't deal with that. So I changed that out once I got, of course, the rest of the scope going in. The scope works perfect. There's nothing wrong with it because I ended up preparing the attenuators and went through everything else. But the thing I didn't do, which I should have did, was didn't change the NVRAMs out because it was working. And I need the scope because my lovely HP Agilent Keysight 3 Series, MSO decided to die. And unfortunately, that scope's a whole nother video, which I'll do down the road. But originally, the power supply failed on it. I repaired that. Then ASIC 2 on channel 2 failed. Repaired that, which I had to buy a donor board to take that chip off to put it on there. And then now the FPGA and ASIC 3 is bad. And unfortunately, the FPGA on the donor board that I still have is also bad too. So it's going to pretty much make that scope unrepairable because to find parts for it is next to impossible. And the parts cost pretty much almost as much as the scope. So I'm not going to repair it. It's not economically feasible. Unless I happen to get one dirt cheap or something like that. But then it's a known issue with that scope. That's why I said I'm going to do a whole nother video on it. And, chances are if you get the donor one, I'll have the same problem too. So I don't know what I'm going to do with that scope yet. But I had to use this one. So, I didn't want to take it out of service. So I'm shocked that these held up. Literally, because I got the scope back in 2018. So it's another 5 years. And it didn't corrupt the data sooner and only died 2 weeks ago. But it has to do probably because I was using it, so the scope was on a lot. And due to that, it wasn't draining the internal battery as fast because these do have an internal battery in them. And they don't charge. So once that battery goes flat, you corrupt your data and that's it pretty much. And your scope will not boot. I did a video on how to actually replace it. So I didn't do in this video desoldering and all that, because I did a video of that already showing you how to do that and stuff. And, it's kind of boring anyway. But either way it goes, though, you do want to be careful, obviously, though, that the pins are loose before you try to pull them, because you don't want to lift any of the pads and stuff like that. So take your time with it. Add fresh solder, of course. Then go ahead and do the same thing. And, I use pretty much this thing here and suck up the solder through the gun, and then do it again. I do it a couple times just to make sure all those pins are loose, and then you can pull them off. But I'm going to go and put the cover back on this thing and hope that there's no other problems with the CPU board or stuff like that. And hopefully the scope will be back to life. One of the other repairs I have to do, and this is due to my lovely bird, decided to fly up while I was working on this. You can see the beat mark right there. She grabbed it, tossed it, and she pretty much broke the front and bent a lot of parts and stuff, which I ended up trying to repair. But what I was doing with it was I was originally just trying to clean the heads, and I walked out of the room, and that's when she attacked it. I guess she thought it would eat her or something. I don't know. Either way it goes, she broke it, so I ended up getting another one. So Go and put that back in there, and that will fix that problem, of course. So there's the new floppy drive. And right on my arm is what caused the failure in the first place. Yeah, you know what you did. You did it, though. Yeah, you broke it. You threw it off the table and thought it was going to attack you. But there's the remnants of the old one that you destroyed. But got a new one in there. They cleaned the heads and stuff. So hopefully that'll fix that issue. But of course, you know, we have these scopes. One of these is probably not going to be the failure. So went ahead and put the scope back on top of the signal generator. And I did put the cover on there. Now, some people run them without the cover while testing it. It's not recommended because what will happen is you'll end up burning up the custom ASICs on the acquisition board. If you do have to run it with the cover off as you're troubleshooting, make sure you blow a fan across it, of course. But let's go ahead and power it on and see if those NVRAMs fix the booting issue. I went ahead and loaded the firmware onto it. You can't just put blank NVRAMs because it won't boot. Let's go ahead and see. Come on. Work. Yes! It's booting. It's going way past what it did before. Yep, and there you go. It's running the self-test right now. Hopefully we'll get a pass too, because you never know. It could be another issue to the CPU board. Let's just see. Okay, come on. You can show it. Show pass. Yes, I think it's going to. And let's see what it says. Yes, it passed it. Good. Let's see what it does. Oh, it turned on all the channels too. Okay, and let's go ahead and see if it actually kept any of the calibration. And yes, it shows all pass. So there you go. It is working. I'm going to go and run this obviously for an hour. Go and do the SPC compensation so I can get rid of the offsets and stuff like that. And the scope's back alive pretty much. And of course you got to set the date and time because you can see that's way out. Obviously, but yeah, it is working, and I do see the 5.2E, which was the original firmware that was on the old NVRAMs. But yeah, it works, so I'm happy at that. So let me go and run this for a little bit so that way it can warm up, and then I'll go and run the SPC on it. So just finished signal path compensation, and it passed the first time around, which I would expect it to because I did repair the attenuators probably back in 2018. When I had the problem, I had to replace a capacitor, a DAC, and all the relays on there and stuff to get that working correctly because the gains were off and stuff like that. But yeah, it did pass. Let's just see if we get that offset it was doing when it originally started, because this firmware was actually a dump from another oscilloscope, so it had a weird offset. Yep, no more DC offset. That's gone. It's back to normal again. So I'll go ahead and hook it up to the signal generator and see how it's looking. So I went ahead and did give the waveform generator some time to warm up. You can see right now I got it set at 1 kilohertz, 2 volt peak to peak. Let's see what it does. And there you go, it's bang on. Sorry for my birds. Let's feed channel 2 and see if it does the same thing. I expect it will work too. Okay, and then we gotta do trigger. Yep, bang on. Let's go to channel 3. Let's trigger on channel 3. Of course. Bang on. Alright, and then let's go to channel 4. Okay, and then we'll trigger on channel 4, of course. And it should be good. Okay. Let's turn off channel 4. And it's bang on. So yeah, that's working. We'll go back to channel 1. Okay, and then we'll just go ahead and look at other waveforms. I already know this all works because it worked before, so we'll go ahead and just, for the hell of it, we'll go to 1 megahertz. Baby, you can't go on me right now. Okay. There you go, and there's a 1 megahertz signal. Alright, and then we'll go ahead and look at triangle, square, and then boss, and then there you go. And she is bang on, so yep, that's good. And then let's go 5 megahertz. Okay, and then we'll go square wave, and then we'll go and look it up, and yeah, and then we'll go 10 megahertz square wave. Okay, and then here you go, and you can see, very good. So yep, this Tektronix TDS784C is fully functional.